So good morning, everyone. Again, this is Unai Ayucar from Alias Robotics. I am the CTO of the company, and we are a company which is dedicated to cybersecurity. I'm going to explain a little bit who we are, and then I'm going to start with my introduction. So this is a cybersecurity talk. This is about how robots can be secure or unsecure, and I'm going to try to explain it from an industrial perspective. So let's see if we can get to have some concepts clear. Who we are? Fine. We are a company that has been on the market for about 5 to 6 years, and we have encountered more than 1,200 vulnerabilities pertaining to robotic systems. That means that almost any robot that we have encountered has vulnerabilities. Is this bad? No, it's the reality. It happened also with all the school systems like computers when we were talking about 2000, the era of 2000, and now we have it with robotics. Why? We start to connect robots that weren't connected before, and we have to analyze also the cybersecurity aspects as we do with the safety. It's another standard that is coming. You have regulations, everything is concrete, and we are starting to somehow start fixing those problems. You have also a specific database in which you can find some of those vulnerabilities, analyze them, and see which ones affect which robot. And also, we have a lot of, and I'm saying lot of research done on how to proceed to understand and evaluate a robot. I'm going to show several robots in these slides and presentations. Don't get the brands, does not matter. It affects to all of them, or almost all of them. The only one that we couldn't hack properly was the Thermomix. The robot for cooking, that one. The rest, the ones that work in the industry, we were almost able to hack anyone. Why? Because they were not conceived securely. And that's something that is common practice for the roboticists because they are doing robots, not secure robots. And nowadays we are moving towards that security. So don't worry about the brands. Do not look at them. That's not the important part of the talk. Okay. This is the status of today. We started having PLCs, we started having machinery that was a little bit connected for monitorization, and now everything is modular, everything is connected, and we have 5G all over the places and stuff. ROS is able to interact with different robotic systems, and that's the situation. So in that super connected, in that hyper connected era, how can we protect our systems, or which is the status? This is what Purdue suggested in the University of Purdue, which is a model divided in 5 different levels. Those 5 levels, for me, are like the playbook of cybersecurity. That's how an industry should be structured. The reality is that it is not the case, and we will see it later. But mainly, what we can see is that we have a first stage in which our servers are, the IT area, where our engineers, computers, administratives, and everyone is. Then we should have a DMZ zone, which is a gap between what industry sees and what our IT system sees, with several firewalls interacting between the different networks. Afterwards, we have the level 2, which is the control area. This is where our ROS controlling system lives and where all our systems can be controlled and monitored. And finally, we have the controllers of our own robots, different brands, doesn't matter. And finally, the endpoints, the robot itself. The level 0 is nothing to do with cybersecurity. That's electrical. We cannot enter there. Cybersecurity enters when we have computing capacity. So we start looking at the cybersecurity from the level 1 on, which is where our controllers of the robots are, where our actuators are, where our PLCs are. Why? Because those ones nowadays have processing capacity, and that one can be vulnerated. Doesn't matter if it's an open OS, doesn't matter if it's a proprietary OS. That's not the point. The point is that they have the capacity to compute and to communicate. And that is where cybersecurity enters. I'm going to go a little bit fast because the presentation is a little bit long just to generate an impact. So excuse me if I am too fast for some of you guys. Okay, attacker mindset. What does an attacker look when he is going to be attacking a system? Well, the first of all is defining a target. We want to do something, okay? With that something, what we are looking is for damage, money, or information. If we look to traditional systems, we are going to look for information many times, because with information we can drop bank accounts and similar concepts. But if we go to robotics, damage is the most key part here, because we can stop a factory, we can ask for ransomware saying, I don't know, hijack robots, for example, as an example. And then we want to gather information to be able to execute the defined attack and look for available tools. If someone has done it before, don't do it yourself. Okay, these are really famous attacks that happened in the last 3 years, in which we can see losses of 400 millions in the USA, many of them. And the point is that US is one of the most so-called open countries when it comes to telling which are the attacks that have happened, but in Europe we have the same examples. I just wanted to show you the amount of money that it's lost, and lives in some cases, with this kind of attacks. And everything is to show that since 2019, we have several attacks put together in different robots, just to show that the robotic systems are part of this problem. Not only the communicated systems or whatever. These were videos, we cannot see them. This is a PDF, I'm so sorry. But basically this is a MIR, or a mobile industrial robot, an AMR, that has the PLC deactivated via Wi-Fi, and that hits elements, so the safety component is broken. Now safety cannot be ensured if cybersecurity is not in place. This is a KUKA, so I don't mind who is here. Don't take it, I mean, I could do it with Fanuc and many other robots, doesn't matter. The robot is not the important part here. Well, it is, but not that much. So the point is that this one has a ransomware done by network, and this one has a ransomware, which is another famous robot, which is collaborative, done by USB. These are just simple examples of any robot can be hacked, okay? And now, typical attackers procedure. I'm going to present you Martincho. I am Basque, Martin is a Basque name, and this is a colleague of mine. I don't know him at all, okay? And he was asked to hack a company with us today. And we are going to go through the procedure of hacking a company, okay? He's a really gentleman, and he has no bad ideas or bad intentions, but, I mean, come on. He has been somehow threatened to do that, you know? So he looks for the company that he was told to be hacking, and this is a pharma company. You can imagine one that was doing COVID vaccines, okay? And we have two levels in the company. We have operations level, so a storing room, and we have a level in which people, normal people, current people, goes to do testing so that they can get more vials to afterwards analyze and process and get the vaccines. So Martincho comes here because he didn't choose the company was chosen, and he said, okay, how can I enter into the company? The first thing is that humans have errors. So basically, he tries to explode somehow the human error here. And he says, this company is trying to get vials from people, I'm going to go there and offer myself. But instead of Martincho, I'm going to enter for the main door, and I'm going to call myself Alfredo. That sounds somehow sexy, okay? And he enters into the room, he gets to the reception, he gets the name Alfredo registered, the receptionist says, hey, Alfredo, and he goes in to talk with the doctor, where he sees an AGV running, okay, that takes some vials. So suddenly, when he was going around, he saw an access point, he saw two closed doors in which communications and lights were happening, and he saw also the AGV. The AGV went out, took the vials, and went into the elevators of RMF project, because this is something fancy that I wanted to introduce. Doesn't matter, it could be in the same floor, but it was just to make a visualization, like a separation between the different floors, okay? And he doesn't know what happens here, because he didn't have access, but he saw this setup. From this point on, Martincho says, okay, lucky me. And you say, why? Well, I was expecting something like the Purdue diagram, okay, super separated, no areas related, and we have an AGV going up and down to an logistics zone. I have completely entrance to the factory. The servers were in the same floor in which I was connected, or at least in which the doctor analyzed me, and there is nothing to do with this structure. And he started saying, okay, let's dig a little bit more. Why? Because from this point on, we can start analyzing how this structure is constructed. And why would do that, Martincho? Well, the point is that if you understand how the system can be risky, you can exploit those risky parts and enter into the factory. And he starts saying, okay, let's analyze who could be collaborating in this infrastructure. And he starts listing agents. Those agents are the robot manufacturers, because he at least saw one robot. He says it should have been an integrator here. I mean, someone has to put that robot into the place. And then he starts saying, okay, it was a security operator, the receptionist. Then we have the laboratory operator, the doctor that attended me. Then we have also a storage operator, because I assuming someone is taking care of the robot when the robot leaves, and the different people related to the company, which is possible. And he started analyzing which kind of communications could be in that building. And he starts seeing that we have Wi-Fi, that's for sure, there were access points, and the robot is connected somewhere. It has to be a server, that robot is not running alone, and so on, so on. Okay, so Martincho goes and does this diagram, but he really does not know this part, neither that part over there. But he has this part in the middle. And he says, it has to be a server, as I said. The IT team was actually taking my notes in a tablet, PDF, whatever you want to. The receptionist, the robot that I saw, an elevator, switches, probably, normal stuff. And he goes and says, okay, I need more information. This is not enough. I have analyzed how the infrastructure could be connected, how those assets are interacting one to the other, but it is really what I was actually needing for hacking the system. And he starts saying, okay, I know that the server should be in an area, which we are going to call trust boundaries, that should be alone. We should have also a clinical area that no one should touch except from the doctor. We have the tests, which is where I entered. We have robots, or robot for the moment, that are down there. It has to be the electrical components. So this is what it is usually done by any cybersecurity experts, with this separating the network into possible trust areas. This means that from the server, if it's well configured, we should not be able to jump to the access point. From the robot, we should not be able to jump to the server. And those areas in the middle in which you see frontiers, those are the points which are called entry points. It's an area from where you can pivot from one area to the other. And that's where the attack happens. You cannot enter into a company like if you want. The idea is that those areas are the points in which you can find vulnerabilities to escalate through different bias. Okay, and he starts analyzing the components that he saw and says, okay, the server, I'm pretty sure that they are using encryption. Come on, this is a pharma company. They are not stupid. Mobile apps, they leave records and tracks onto those apps. That's not interesting neither. Oh, I was unlucky. The access point was ubiquity. It's the most secure in the market. Let's try with another thing. And he sees a robot. I don't have any idea of robotics, but it's the only component that seems to have an opportunity over here. And he starts looking for reconnaissance tools. He sees in the internet that exists Artarna, and you say, that kind of tools does not work. Actually, they do. We saw it in ROS-I a couple years ago, that we found different robots in the market available and completely open for everyone. That's a tool that, in this case, was developed by Alias Robotics, but doesn't matter. There are many for finding robots in the network, okay? And this tool actually showed him the different robots that were available, and he encountered that it was not only a mirror, but the other robots that I have shown previously. This one, which is industrial, it's orange, but don't take a look at the color, okay? And this one that has also a really particular color, but that's not the important part on the talk. I have said it. Okay, so here is where we are. And Martincho says, okay, it seems that the robot is the more feasible area to enter, so I'm going to go for that one. And starts seeing that the robot itself, which is where we find the vulnerabilities that we are able to exploit, has an access point. That means that the same robot is actually providing Wi-Fi, so you can connect to it. And I don't know if you know it, but there are some directional antennas that are really cool that you can point to wherever you want and amplify any Wi-Fi that is existing. So if this robot was actually presenting Wi-Fi, and anyone from outside was able to just point to wherever the robot was, well, they could connect, okay? And we see that you are presenting some access points that are available to the robot which shouldn't be. Why the robot itself is presenting a Wi-Fi? Because for the developers it's more easy to develop anything. Yeah, but that's unsecure, we shouldn't have it there, guys. Developing and production are two areas, separated, please. So this is how he entered into the robot at first. And next he says, okay, lucky me, this system has ROS. And he starts seeing which are the topics that ROS discloses, because we are inside the system. So that means that even we are using ROS2, I can see the nodes, the topics, and the graph. That means that I can see the components that are around the robot. So in case I couldn't, or I was not able to actually get the brand of the robot, now I have all the topics and all the components related and connected via ROS. That is showing me the information. And you say, but that's how ROS works. Evidently. But we should secure who can access that information by authentication, not only in the link between robots, but also inside the robots. And you'll say, but ROS2 is now secure. And I'm going to say, almost. ROS2 is implemented in DDS, and this was a Black Hat talk in which we were able to show that DDS had vulnerabilities. Does that mean that ROS2 is not a solution? No, don't get me wrong. Any of these devices which I am pointing today, solutions, DDS, whatever, are implementable solutions. The thing is that we have to take into account that they are not secure, and we have to take the measurements so that we can implement secure robots in our networks. That's the simple message. It's not, hey, ROS-I is not secure. No, neither OpenSea UA, so don't worry. I mean, it's not about the protocol, it's about the configuration. You have to take into account the risk so that you can provide a security version of it. Okay, so we have AMR Atomic, okay? And this is the robot in which he was able to enter. And thanks to ROS, we were able to see that there were different components connected via the ROS graph. And we see that there are actuators, sensors, a SIG PLC. That was really, really appealing and a good information to get. And from here, he was able also to get the brand of the robot, from where he started looking in the internet how it was constructed. Lucky him, he found that the robot was this kind, and he started doing some, analyzing that they were phonics contact with Tugger, Schneider. We have Philips also in some parts of the Siemens, SIG, motors. Well, that's an analysis that a cybersecurity engineer should do, which is look what it is inside and what it is vulnerable. So here it goes and says, okay, let's try, because that would be so funny, no? That the PLC is connected actually to the NUC in which I got access from the Wi-Fi that the robot was providing, and that actually had a default password. Lucky him again. The password was default in the SIG PLC, was connected to the NUC of the robot, and now the robot is crashing all over the place. So we have fun again. And what you didn't notice is that Martinch at that point, actually he got his objective, which was generating a disturbance into the company. Nothing more than deactivating the PLC, the SIG PLC that it's running over there with a default password. It was an easy job. But as Martincho is a really smart guy, he says, I'm going to get more money. Oh, better, my life is going to be more secure if I am able from here to look to the manual of the robot, which I haven't checked yet, and see if I can get an escalation of privileges. Because all the passwords are default in the manuals, because robots are super programmable, and that's super cool, but then we oblige the companies to have the passwords on the manuals, which is not super cool for cybersecurity. And he do escalation, and he's able to enter in the server and whatever. So this is what Martincho done. This is a video also that we are not going to be able to see, in which a robot, an AMR, it's showing the map of a building. So he didn't know any idea of how the logistic area looked like, but he entered into the map, and now he has a small reconnaissance of the place. Shall we go for another robot? Yes? Come on, please. This is a talk, and he's a good guy. He just did his job, and he's leaving. So I'm going to jump for the next part, in which is securing and protecting robots, which is like the other part of the talk, okay? Typical security flow. We have threat modeling, assessments, which is related to penetration testing and certification. This is how Alias Robotics, one of the verticals that we have, help companies. We evaluate different robotic systems, we evaluate the industries, we evaluate all kinds of services, but the idea is that a threat model is a risk analysis. Do you remember those slides in which I was somehow painting lines with dashes and doing like the reconnaissance of the different communications between the robots? That's a risk analysis. That's how we can actually understand which are the possible risks that affect to our system, industry or robot. Then we also have the pen testing, red teaming areas in which, as I did afterwards for hacking the company, I started encountering different vulnerabilities on the system, that those need to be listed, need to be addressed, and afterwards need to be patched, if possible. Or at least obscure them, which is not the via that Alias, the via that Alias Robotics recommends, so that the ones from outside cannot see the vulnerabilities, because another point is somehow twisting the vulnerability that is not available for the rest of the people that can hack it. But well, at least put in a solution once you have encountered those problems. And then certification, which is, we have a lot of standards, and now, thankfully, with the Cyber Resilient Act of Europe and with other IEC 62443, which are standards of cybersecurity, we have security levels defined to be able to continue procedures that allow us to have security in our devices. Among them, the robotic systems. And the MDR, which is the medical device regulation, has also the security part now. So it's only looking at the standards and having a little bit of care of what we are implementing in the robotics world. Protecting endpoints. So basically what we can see nowadays is that we have all the computers protected with McAfee or antivirus or whatever, which are monitoring systems that at the end give information of the different vulnerabilities that may happen to the system, to the computer in this case. Now, in the OT network, we have different solutions, which are from different vendors, and I don't care who is the vendor or whatever, which would do is monitor the different communications. If we look to the Purdue diagram, these ones act in the level 2 of the network. So they were just below the DMZ zone, the one that is divided with firewalls. And what we have in robotics? Well, we are alone. No, Alias Robotics has a small product which is called ROS-I, which we don't care about, but the idea is for you to understand it's interoperable with different systems, and it's, at the end, how we should approach it. ROS, for example, generates logs of what it is doing. So that, for example, could be converted into a cybersecurity solution, because at the end, tracing what the robot is, or what is happening to the robot, is implementing a small monitorization tool, which is considered under the scope of cybersecurity. It is not rocket science. It is not doing something that no one can do or entering into a new space. It's simply notifying what it is happening. And at the end, we have all the connectivity on our robot. So we could, or it's the best part to be inside the robot to be able to monitor those systems. This is an example in which you see our solution integrated with other vendors. But at the end, the idea is to have something inside the controller, as we have for the different computers over here, which are in each of the machines, not simply for the network, which are the ones in the middle. And this will be all. I wanted to present, thank you, Endika. Endika obliged me to put that we have just opened the Robot Security Evaluation Lab in Vitoria this week. So this is a new, we can evaluate now ROS devices and also other kind of robots. And we are credited for that with the European Union and INCIBE, which is a CNA in Spain. So thank you so much for your time. I'm sorry for being that noisy, but thanks again.
Thank you so much, Unai, for your wonderful presentation on security and vulnerabilities and ways to mitigate it. So now let's go for questions. Yeah.
Thank you for your presentation. I have a question. Where do you monitor your traffic or your threat? It's a separate, let me see, node, which you install and monitor, for example, CPU usage or threats, and how you detect the attack. Or do you have special kind of hardware which monitors the traffic and detect this attacks or whatever?
Sure. Thank you so much for the question, first of all. And okay. So the thing is that luckily we have different implementations over here. I'm going to go to the Purdue diagram because this is where we can see it more evidently. One sec. Here we have one. So we have different levels. If you look to the monitorization techniques, they are usually running into servers which are placed into the client's facility. They can develop their own servers and they place them over the industry so that they can provide the security, but usually those ones are deployed into client servers. If you look to the other devices which I was pointing, which are the computers, which are in this area, the McAfee or other kind of solutions, they work in your laptop. So that's your machine. It's your own computer. And the idea with RIS, and the one that I'm proposing also to extend for ROS, is to run in the controller. Thankfully, we have the capacity in the controllers to do much more than what the robots are doing, in many cases, at least for the new ones. If we go to the legacy ones, it's more complex, and we should put something in the middle that allows us to monitor that traffic.
But is it like a road node, a ROS node?
It could be implemented inside the ROS node and have the capacity to have a controller that gathers all the data. For example, RIS as a node, it's installed here. And what we do is pass all the information to all the OT, or the ones that we have a collaboration with, monitoring companies, so they gather it in a server. And from there, you can manage it upwards to a SOC, which is a security orchestration system, or whatever you want to call it. So basically, you can gather it from the endpoints, from each of the nodes, and afterwards gather it into a more centralized node, and from there, go wherever you want. So the robot works for that.
A ROS node that watches over all the ROS communication instead of having one on each of the devices?
It does not. It does not, and it's because of the zero trust architecture which is defined. So that was the SROS approach, watching or somehow understanding how ROS was interacting in the node. But the thing is that if you look to the zero trust approach, each of the nodes has to have its own security. That means that this robot is giving information about its CPU, about how the velocity of the actuators are working, the temperature of the CPU. So for example, if I am not able to track an attack via network, at least I am able to see that the robot is fluctuating in its behavior. And I can monitor that fluctuation by being inside the robot, not in the network. The network only shows me what I am displaying to the network. Being in the robot shows all the things that the robot is receiving, although they are not displayed in the network. An attacker can obfuscate itself so that you cannot see it as an IP, but it can tackle a specific robot. The thing is that if you are the one receiving the attack, there is going to be a way in which you are suffering it.
But
That thing, you have to pop it up.
But you need to learn, let me see, based on the data which exists right now. So you need to learn this, let me see, levels of the security levels.
So the thing is, there we go, sorry, the presentation is really long. So here you have, this is a training, sorry. This is a training circle in our solution, that was our proposal, in which what we do is set the system for training, okay, like the ones that it was a reinforced learning that was showing yesterday a colleague of us. So this, what it does is learn what the industry is doing, learn what the robot is doing, monitor all the communications and generate a whitelist. Afterwards, it checks the anomalies or the differences with what it was learned. That was our approach.